I know I've not been doing very many videos recently. I'm sorry for that. Just sort of been getting on with things really. But one thing I have got to do, up at the big telescope, we've been fitting some digital setting circles, which are devices which allow you to detect where the actual telescope's pointing. And the way that they work is that you use these rotary, these encoders. This is a rotary encoder, which has this particular one's not particularly precise. It has 4,000 ticks, so it generates pulses out of this contacts here, and it has 4,000 per revolution. So one of the reasons I'm quite often on the higher tick ones, they go up to 10,000 ticks, and that's the ones we really wanted, but they're quite expensive. You fit them on the actual axis of the telescope like that, and then wherever the telescope's pointing, you get 10,000, an accuracy of 10,000 per revolution, which is pretty good. This is only 4,000, so if you were to do that with this, you'd only get sort of like a tenth of a degree, which sounds quite accurate, but when you're pointing a big telescope at the sky, it isn't a lot of resolution. Things will very easily not be in the eyepiece with that sort of resolution. So what I aim to do, I've got basically the way that this is mounted is going to be on a little swinging cam, and what I need to do is make a wheel which goes on there, which is like an idler wheel, an idler pulley, and that will rest on the axis. So rather than being 1:1, it's going to be about a 4:1 ratio. So this should be around about 12,000. Push this up to around 16,000 ticks per inch. So we'll get a much better resolution, as well as the fact that it's easier to make it work in this way. And so what I've done is I've bought an O-ring, a 4mm by 110mm O-ring, and I've got to make a disc of aluminium to mount that on to make it into an idler, which was obviously going to be a nice fit onto this shaft as well. And then on this is a spring-loaded cam follower thing, and it'll mean that the wheel will rest on the pinion of the trunnion of the telescope, and it will measure the elevation in this case. I've got the other axis to do as well, but I'm going to do that differently, but so it's just a quick one today. We've got to cut a disc out from some plain aluminium. I've got a sheet of aluminium for like 5.5mm aluminium, so it's 1/4 inch aluminium, and I've got to cut a disc out, turn it down, but I'm going to do all that on a mandrel, so I've got to make a mandrel first, or an arbor. Is it an arbor or is it a mandrel? Not quite sure. I've got to turn a steel thing in the lathe so it's accurate on centre, hold it in there, and then accurately turn the edge. That way I'll get a very, very concentric bore through the plates as well as the edge, so that obviously there's no error when this is rotating. It's rotating linearly, if you like. If it's sort of eccentric like this, you're going to get false readings. It's going to, the accuracy is going to wander from backwards and forwards. So it's very important that this is completely concentric to the axis itself. Hopefully the actual axis itself is completely concentric to the rotational axis. Let's fingers crossed. Hopefully John Wall did his job properly there, and we'll soon see. But if there is any inaccuracy, it might not be super critical or important. We'll have to see. But anyway, here we go. There's a disc. there's a hole there. I scribed the line for the middle, so I'm just looking to make an arbor for this now. Stick it in the lathe, turn it down, and hopefully make a pulley out of it, which will ultimately go onto this encoder here. So I've got to decide how I'm going to do the centre, whether this has got enough meat on it, which I don't think it has, but what I could do is just make it a very nice snug fit onto here. This is exactly 1/4 of an inch. So if I can find a reamer that's absolutely bang on 1/4 of an inch, we'll give it a go and we'll see if we can just get a push fit onto there, but it's probably a bit of a long shot. I've got this piece of steel which I think came out of was a shaft from a printer, so it's good stuff, but I'm not quite sure what it is, so we'll give it a go and see how it turns. So start by spacing this off. It's a golden tad. On the centre, so good place. Okay, now just need to work out how what sort of depth I need to go to. So what's that? That's 9.6. So this is actually 6. So just a little bit further. About like that. I'll just set my 0 on there. Right, we'll take that down to the regular chip there, creep up on it. There's nothing worse than going through all that and then going overshooting and going too small, because it's sort of a waste of bleeding time. You have to do it all over again. 257. So let's link a little. I want this to be really accurate. Actually, I'm going to go for my just gone for my Mitutoyo just to, I mean the others are Mitutoyo, but go for my digital ones because they're a little bit more accurate really. Not that I can get this level of accuracy. Right, what's that reading? That's 2, 5, 6, 8. So I'm going to take 6 off, and then I can always polish it absolutely cock on. So from there, 6 is 3, 6 is about there. So let's see what that gets us to. Put some of that on. make it there just in case when I can come out. Because I want to get it cock on, so I think it should be pretty well on there. .252 apparently. Let me just come out of there. And we'll just measure it properly. Yeah, it's definitely 2528, so it's almost 3000 to come off from there. So if I do 2, a little smidge. Let's give it another go. Confident this time that I've got it, so I just backed out to get the shoulder nice and true, because I'm using it as an arbor. I need that. Oops, get off. I just need that to be useful. Right. Let's see where we're at with that. That's 250 and 2/10 apparently. Let me just do it again, get an average. 250 and 2.5 tenths. Let me just turn it around 90 degrees, do it again, just see how triangular I've got it. 250 and 2.5 tenths. Let me just do it at the end. It's probably got a bit of a burr on that, that'll read higher. That's 250 and 1/10 at the end. 250 and 1/10. So a bit of deflection on there. In fact, it's 250 and half a tenth. If I do it carefully, if I get it right up at this end. 250 and 2/10. Yeah, so I've got a 2/10 taper on there. It's actually slightly thinner at that end than that end, which is fine because it'll go on there and be absolutely fine. Now, what I need to do, I just need to make this bit here 6mm, because I'm going to put 6mm nut on to hold the plate for when I'm turning it. So it's only this back bit that's critical, which is really accurate anyway. So I need to turn this down now to 6mm. So about well, I've got the disc itself is 5.5mm thick, I think. So if I so what I want is about 5mm, so that's about 5mm there. So let me just mark where I need to take it to 6mm, so it's about there. So that bit there, I don't know if you can see that, but where the hang on a minute, straighten up. So where that black mark is there, that bit there I need to take down to 6mm. Currently it is 6.5, so I need half a mil off. From there, about 14 down. .236, so that's cock on 6mm. 6.12 going to that, no, Oh, that can be what it's for. Yeah, 6 mil, 6 point, you know, near as damn it, 6 mil. So let's just get a 6 mil die, and we'll put thread on that, ready for the nut to do the mandrel. Just going to put a quick chamfer on both of these before I do. For action, so I'll just get my set up for my threading. We'll just push that up against the back to keep it true, and hopefully, I've got to lock it first. Right, there we go. Well, we'll just get this turning. Nice and straight. Now, let's get it into a low gear. There we go, nice low gear, so it's held tight. I think we've started, so that's good. Yep, it's going all relatively straight now. Just keep straightening that up. Right, you can probably back that down now. Let's see, there, and we'll just get that on there. You see the steam coming off the it's so cold in here. I think that's going to do it. That should do it there. So there's our 1/4 inch section. Let me just wire that. My 1/4 inch, the thread goes, yeah, 5 mil, so it's about 5.5 mil is my plate, so that's going to go onto there, and then we'll just thread her on. I'm just going to an M6 nut, just to make sure that's right. There we go, and that's going to hold the plate on. Enough room for a washer as well, so that's good. Okay, what I've done is I've screwed 3 cap head screws on there, and I'm going to put that over the top, so I've got some clearance underneath to drill through and ream through. So all I've got to do now is just clamp this down in a couple of places, probably will do it, and then we're good to go. So I'll just extend those legs down a bit. That. Tighten that down. You can dish it slightly, but it doesn't matter. I'm going into that hole in the middle, and then we'll ream it as well to 1/4 inch. I've got the reamer here ready. Just need, we'll probably put a 6 mil hole through there. Right. 6mm. I'm just going to stick a 1/4 inch reamer through it now. Right, so there we go. Let's slow it right down. That should do it. Into loop on. There we go. That should do it. Hopefully, that's going to be a nice tight fit on the mandrel. Let's have a look. Okay, so there's the disc. That's the burless side. So let's just wipe that off. That hopefully this should be a nice. Something going on. It is. It's going on. There you go. Nice tight fit on there. It's not a very big mandrel for turning something like that, so we're going to have to be pretty careful. But that's the washer and the nut on. Let me just get a spanner. Find the right spanner, so it's going to have to be a. Can you hear this ringing on that? That's going to be a real problem when we turn it. Right. That's going to be nice, isn't it? That rings a bit. Because it does get you quite close if you use it the right way around. Right, let me just get that back so it's on the edge. Right. There we go. That's too high. I'll just lock that down to try it. Nope, still too high. Got to get the bubble in the middle. Speech lower. Right, that's pretty much on the centre now. If you're not using one of these, they're actually quite good. Edge precision, and you calibrate it off the top of your machine. You know, if it's when that's level, rather off the you can basically calibrate it anyway, and it gets you really close. I mean, really close. But this, I think, is. Where did I get this? I got this at one of the engineering shows. Wasn't dear, but they're all right. They're all right. Right, that looks pretty much on centre. So that has to be a good thing. Now I'll just head it slightly, that way slightly, looking at the way the mark was left. Too bad. It's got reasonable. I mean, it has got chatter marks in it, but as I say, I'm not entirely bothered about that because I'm hoping that the tyre itself. I mean, a bit of just a bit of polishing up there. I'll probably get rid of those. They're only really, you just feel them when you cleaned it. That doesn't look too shabby. Right, let's see if we can get this on, because that's obviously important. It's covered in greasy grease now. It don't help when it's covered in greasy grease. WD, that is. Right, so that's it there. Oh, that's great. That is perfect, man. It's on there tight enough to grip, and it's gonna do the job. So this is it mounted on. This is the encoder here, with its 1/4 inch shaft, and it's a really nice tight snug fit on there, so it actually hangs onto it absolutely fine. Ultimately, I may just put a drop of low, low adhesion Loctite on there. But the good thing is that all it has to do is that. So, and it's working absolutely fine. It's actually moving the encoder around, and it's fine. There's no sort of back, and it's quite nice having a bit of weight in it, because I think it's going to, I don't know what it's going to do. But anyway, it works a treat, and the tyre doesn't seem to slip, and it moves the encoder around perfectly. So that's just going to, the encoder is going to go up on the axis, the trunnion of the big telescope. So as the big telescope turns, it's going to turn the encoder around, and obviously tell us where it's pointing, which is always a good thing.